Okay, so we have this. Are you here? Are you there?
Yes.
Okay. Okay. So we have these three aerofoils with us from previous class. So if you remember, we have this is our geometry from the paper. So like this. Okay. So now the idea is that actually this case has because the turbine blade is rotating. Okay. So we have to create the rotating zone, but that is only limited to that particular location. So the idea is that if I draw this very rough diagram, the idea is that like we have the wind turbine blades here. Okay, three blades are here, and they are apart by like 120 degrees from each other. Okay, so we have to create one line here and one line here. Sorry, it should be somewhere here, and one line will be here. So there will be like one domain will be rotating with a given RPM, and that RPM actually we found out from the given TSR value. Okay, so this whole domain will be rotating with a given RPM, whole domain. Okay, and because this blade is part of this domain, so this also will be rotating with this fluid domain. And then inside we have the one domain that will be like I would say is inner domain. This will be the like our turbine, our rotor, the rotating domain, or whatever name you want to put there. And there will be outside domain. That outside domain will actually will model the flow. That will be the atmospheric conditions. Okay. So the point is that the domain size of the outside will actually will be taking care of the atmospheric conditions in the like vicinity of wind turbine. And the point is that they should be away from wind turbine so that the conditions on these boundaries, they should be same as atmospheric condition, and they should not get disturbed with the presence of the wind turbine there. So they should be large enough so that we can ensure that the atmospheric conditions are present everywhere on the domain. So there will be three domains. Uh, this one will be fixed and outside domain will also be fixed. Okay. And this domain will be rotating with a given RPM. So there are three domains, two fixed and one rotating. Okay. Any questions? Okay, so here the idea is very simple and there's no hard and fast rule for the making domain size. So I will go with some rule here that says that uh, this range domain size should be enough so that we can have the enough mesh cells there. And outside domain size, I think that we should take with the help of the formula that says that it should be like 5 times upstream, like here, from center to upstream 5 times. 5 times how what? The diameter. So diameter is equal to the 2.5 meters of wind turbine. So 2.5 times 5 will be equal to how much? 12.5 meters. And the downstream that we are going to keep is equal to the 10 times of diameter, 10D. And the upstream we are going to take is the 3D, and downstream also, sorry, top and bottom will be 3D. Okay, from center to this line. So 3D, 5D, and 10D. Okay, it's clear. So we should put the dimensions like domain size in terms of the diameter of the. This depends on our important geometry parameter. For this, the important geometry parameter would be the diameter. For aerofoil, this will be the chord length. Okay, so this is the way we actually work with the domain sizes. And if you think that domain size is not enough and we are having the problem on the outside boundary condition, then we should increase the domain size. Okay, make it larger. Right now, this is okay. So I will now go on the plane number 4. And here I'm going to actually make the new sketch here. On this domain, I'm going to make the new sketch. Okay. So new sketch. And sketch number 3, I'm going to use a sketching tool and I will create 2 circles. Okay. exactly from this center point, origin point. So 2 circles, one here and one will be the here. Okay, you can also hide this sketch which is here. Okay, so domain size here, it should be enough so that we can have actually the fine mesh around the aerofoil. It should not be very large, it should not be very small. So let's first try the dimensions here and then we can decide about the dimensions after putting the dimension parameters here. So diameter for this one and diameter for this one. I think this should be like we should have keep the same distance from the aerofoil on the inner circle and outer circle. Inner and the radius of the circle from center point is 1250 millimeters. Okay. So I think that the value of the outer one, which is here, it should be like 3000. Or we can try like a 2800. No, this will be very small. 900 will be, okay, make it 3000. Okay. So now 3000 means that its radius will be equal to 1500. So 1500 minus 1250 will be equal to how much? Because the radius of this these aerofoils are 1250 millimeter. So 1500 minus 1250 will be equal to 250. So same distance should be maintained from the inner boundary. 250 means that it should be 1250 minus 250 is equal to 1000. So 1000 double will be 2000. Like this. Okay. So this is the domain. We are creating actually two curves here, and from these two curves, these two sketches, we are going to create the domain here. So again, go back to the modeling tab, click on sketch number 3, go to the concept menu, and the surfaces from sketches. Okay, apply. So one sketch, which is sketch number 3 actually. Okay, and make it edge frozen. So what does it mean? Edge frozen means that this will not my domain with the existing bodies, which are aerofoil, 3 aerofoils. Okay, so make it edge frozen and then click on generate. All right. So and the inner domain we can create by simply go to concept menu, and this is the surfaces from edges. So select the edges, which is the one edge here, and from this edge actually we can easily create the inner domain. Very simple. Okay, so we can save the project right now. Okay, now we have to create third sketch. Third sketch will be for the outer domain. So I'm going to make a the third sketch here. And the box here I'm going to put is going to be the of rectangular shape. Okay, so put it like this. And put the constraint of symmetry. So it should be symmetric on the around the x-axis. So same distance should be from x-axis to the top boundary and the bottom boundary. So select the x-axis and then choose the top and bottom edges. Okay, so distance here will be same now. So if we put a dimension here, let's say the vertical one, same thing I can do, but this will make the problem over constraint because already we have a symmetry condition there. Okay, so simply move this dimension outside. Okay, I told you this should be equal to the 3 times of diameter. So it means that this should be equal to the 3 into 1250. Sorry, diameter is equal to the 2.5. Okay, 2.5 means 2500. So 7500. So 7500 here. Okay, and on the front side, this should be equal to 5 times of diameter. So 5 times means that the 5 into 2.5 into 1000, and the millimeters is set 12,500 millimeters. So 12,500. Okay, and then on the outside it should be like a 10 times 10 into the diameter, which is equal to the how much? 2.5. Multiply with 1000, so 25,000. Okay, so third dimension will be from y-axis to the vertical line here. 25,000. Okay, so now, okay, let me check the slides here. What I did with the domain size here. The domain size was 5D, 10D on the downstream side, but across it was 10D. But right now we are putting the like a 3D and 3D, so it's a 7D actually, 6D. So here I put the like size was the 10D. So we can actually solve the case and we can see that if the both are giving a same solution, then it's okay. But it's not any hard and fast rule what should be the domain size. I know this thing that 5D should be like enough on the upstream side and 10D should be enough on the downstream side. The top and boundary 3D is okay, I think. But if you feel some problem there, you can make it like maybe 3.5 times. So 3.5 into what value? So 3.5 times of the 2.5. Okay. So it should be radius. So it's a 1.25 into. Please ask.
No, go ahead. I was just trying to. Go ahead.
Why?
I was just converting the units to 1,000.
Is there any question?
No question, Prof.
Okay. Okay, so what I'm saying here is that right now we put the 3 diameters from the x-axis to the top boundary and the bottom boundary. So let's make it maybe like we have put the 3D here. So let's make it 3.5D. Okay. So 3.5 into 2.5 and then multiply with the 1,000. This will be like 8,750. So 8,750 and click on generate. So now it's a 7D, 5D and 10D. Okay, let me write it down. It's 3.5 D here, 3.5 on the bottom. And on the upstream side, this is equal to the 5D. And downstream side, this is equal to the 10D. Okay. The purpose of the upper domain is actually, see, the wind turbine is operating in some atmosphere. Okay. So wind turbine is not, it's actually is working in some atmosphere where we hear the wind. So we are actually modeling some portion of the wind that is a part of that particular region. So we can get the like a boundary conditions or the flow from that local conditions. So this is like a control volume that will encompass the wind turbine plus some portion of our atmosphere. Okay. So on these boundaries, actually, we will be having the atmospheric conditions, and their size actually it depends on the only one thing, that on these boundaries we should ensure that the wind turbine blade rotation and the flow will not disturb the boundary conditions on these boundaries. So it should be very much large so that it should not be affected by the local flows on the wind turbine blades. Okay, that's why we are putting these values so that they will always ensure with the atmospheric condition. For example, atmospheric condition means that we have the like at sea level pressure is a 101,325 Pascal, and temperature is equal to the 288 Kelvin, 288.15 Kelvin. Okay. So these conditions, we should ensure that they are always there on those boundaries. They should be far away from the wind turbine. Okay. So it is found like from different people that these dimensions make sure that the atmospheric condition will be there and they will not get disturbed there. So what we need from the upper domain is that we just need the air. We just need the wind from here. Okay. The wind of the local conditions on that local particular region there. So right now you can model it like a 10 meter per second. In some other regions, the velocity might be maybe 12 meter per second. It can be like 7 meter per second. It can be like a 3 meter per second. That's only to model that thing. Okay. And then once the flow goes over the wind turbine, then it will exit from the, to again back to the domain, again back to the atmosphere. Simple. Okay. It's clear? Okay. So we are just modeling the control volume that will be encompassing our atmospheric conditions for our wind turbine. Okay. So now we have to also make the domain for this outer sketch. So select the sketch and go to concept menu and click on the surfaces from sketches. So click on apply. Again, we have to do the same thing like add frozen and click on generate. Simple. Okay. So now we have to actually make the outer domain is actually is overlapping on this domain. Okay. So what I'm going to do is that I'm going to use the Boolean operation. So from the create, this is a Boolean operation, and I will use the operation that is the subtract. So I'm going to subtract this domain from this outer domain. Okay. So choose the outer domain, then choose the rotating domain, which is here. So if you cannot select that thing, and then you can use a different plane. So we have selected that domain, and then you can click on apply. Okay. And then click on the generate. But I want to preserve this body as well. So you can click on the generate. Okay, now how many bodies we have? So we have the one body that is okay, there are different bodies here. So this is I will put the name here. This is the rotating domain. Okay, rotating domain. This one is my fixed domain. So put the name here. It's the fixed domain, means there no rotation will be there. Fixed domain. And this is the inner part. Okay. So fixed domain, and this is the inner part. Okay. Then we have the surface body, which is okay. Surface body. This is the rename. This is the fixed domain again. But this is the outer domain. Okay. This is the outer part of our domain. Okay. So let's hide these two domains here. Okay. So you can see that actually we have the extra surface here. And that surface is created because we intersected this inner ring, middle ring from this outer domain. So it actually divided into three parts: the middle ring, the outer domain, and this domain. Okay. So when we are doing that thing, actually, when we are working with the Boolean operation, so we should not preserve our tool bodies. Should we? Or should we not? So let's see. No, we should preserve actually. We should have that domain also. So you should preserve the tool bodies. Okay. Anyhow, this is the rotating domain. Fixed domain is the inner. This is the fixed domain outer. This body is extra. That actually it's overlapping with the fixed domain inner. So you have to suppress that body. Suppress. Okay. Then we have the three aerofoils. You can see there should be three aerofoils here. One is here. Second one is here. This one, and third one is here. So you can put the name here as aerofoil 1, 2, 3. Okay. So rename. This is the aerofoil 1. Aerofoil number 2. And this is aerofoil number 3. Okay, save the project file. And now you have to actually subtract the aerofoils from the middle domain. Okay. So display the middle domain, which is this one. Okay, so we have to again apply a body like a Boolean operation, and this time target body is this one, the ring of the rotating domain, and tool bodies are the three aerofoils, which are here. So you can select actually them directly. Sorry, this is my domain. And you can select them like three aerofoils by the box selection. Okay. So I will put the box here. This will select the all three aerofoils. I don't want to preserve these bodies because the flow will be over the aerofoil, not inside aerofoil. Okay, so that's why the flow will be having on the over the aerofoil, not inside. So that's why I want to preserve this aerofoil bodies here. So I don't want to preserve them. So I want to subtract the aerofoils from my middle ring here, and I just need the outer surface for aerofoil where the flow will be there. Okay, that's all. Okay, so I will use the same operation and same three bodies and click on generate. Okay, you can hide this domain here. So you can see here that from inside we have this is hidden actually. Okay, you can actually hide them, these sketches. Okay, now you can see here. Okay, so now we have the only aerofoil surface there and internal of the geometry is not there. We can have this geometry, but that is only when we are going for heat transfer or when we are going for the structural analysis like AFEA. In that case, we need the internal geometry of the that particular body. Okay, and make the a selection as a single select. So now we have the three domains: this domain, this domain, and this domain. Okay, any questions? Any questions? Okay. Okay, the next thing is that I need to have the leading edge and so that I can actually have the my own proper size on the leading edge here. So I need to put the leading edge here. And for that, I will go to the tools. And here we have not here, but actually concept menu. So we have to split edges. Okay. So I will use the fractional option. So it will be dividing my geometry at the 50%. 0.5 means 50%. So, and actually you can choose the multiple edges in the same time. So I can choose all three aerofoils in a single go. Okay, and click on generate. So all aerofoils are divided into the two parts, upper and the lower side. Okay. I will apply another operation that is going to be split the edges. So here, I want to put that one as the 0.05. Okay, click on generate. Okay, this is actually making on this side. This depends on the direction of the edge. Depends on the direction of the edge. So you can see the direction of edge is actually pointing to toward this side. I can show you that thing by going to the a view and cross section alignments, or I can show you the display edge direction. So this edge is actually going on this side. This is the side number 1. So 5% will be here. Okay. So it means that this tells me that I should be selecting the not this edge, but this edge actually. Okay. So 5% will be here. And for second aerofoil, I should be selecting this edge. And for third aerofoil, I should be selecting this edge. Okay. Apply and click on generate. And similarly, I will be making the third split here. Okay. Same value, but this time I'm going to put it on the remaining boundaries. Apply and click on generate. Sorry. 0.05, it's not okay here. These are I didn't understand. 3 edges or 4 edges means there are 3 edges right now. There are 3 edges. So let me check. Did I put the 4 edges? Okay, sorry. So one, and this should not be there. Okay, this should be there and this should not be there. Okay, thank you for pointing. Okay, this is making the problem. So 1 minute. This is okay. So let's go for this edges here. Okay. So Okay, so for these edges, I'm going to put the value as the 0.95. 0.95. This is the 1 minus 0.05 will be 0.95. Okay, click on generate. Okay. So now we have the divisions here with us. And here what I'm going to do is that actually I'm going to actually merge these two edges. That I can do. But one thing, if you take a look here, so what do you feel? I think it's okay. Okay. Okay, so now I'm going to actually merge my leading edges, which are two right now. So I will select the edges manually. Okay, click on generate. So now you can see that we have the one edge. Okay. So this is done. If you need the like a two edges, then we can always come back here and we can just simply suppress the operation here. Okay. So right now we just keep as it is. So unsuppress and save your project file. Simple. Okay. Any questions? Okay, last thing is that we have to put the boundary conditions. So I will start with the rotating domain and I will be hiding these two domains here. Okay, so first start with this middle domain. So I will be selecting this edge, right click here and put the name selection, and name would be the interface. Okay. Interface, this is like your rotating domain. So interface of rotating domain. And this will make interface with which domain? This will make the interface with our outer domain. So make it name as outer domain. Okay. So click on generate. Now this is going to be interface with like inner domain. So I'm going to put the name as name selection. This is the interface rotating domain. And this is going to make interface with the inner domain. Okay. And click on generate and save it. Right. So we have these two boundaries are done. Then we can define because we have to find out the torque for all three aerofoils at the same way. So we can select them as single boundary. So select them with press the control key and select them with the box selection. So right click here and name selection. So let's say this name is or wind turbine. Okay, and generate. So we have done this with these boundaries. So you can hide this boundary and show your inner domain. It will have the only one boundary here. So one boundary is this will be interface. Right click here, name selection and interface. And interface is with the inner domain. This is interface for inner domain. Okay. So generate. Okay, here actually, okay. So this and this will make interface together. Okay. Okay, so you can now also hide this boundary, this domain. And now you can display your fixed domain. Okay, so put the name here as the inlet. Okay, generate. And this boundary is going to be the outlet. And we can generate here, and this is our top boundary. And this is going to be our bottom boundary. Okay, this is going to be interface. So interface of your outer domain. Okay, and generate. Okay, now you can display the all three domains together. We have the define all the names. Okay. So any questions? Any questions? Any questions or not? Okay, I will take a 5 minutes break and I will come back. Okay. And then we will start with the meshing part. Okay, should we start again? Okay, should we start again? Okay, you can see that we have the this domain here. But if I show you the animation of the like a water shedding around this wind turbine, so you will see this thing. Take a look here. That the only flow which is not only in the wind turbine blades, but the flow actually get expanded. You can take a look here. You can see here that the wind turbine, their blades are here, but this can be like, it can expand in this way. And especially up to this point, this is very much severe, okay? Very high intensity is there. So what I'm thinking is that I'm thinking to put the like a region of the refined mesh, but only in the region where we have the WEC. So refined mesh and WEC region. So that we can achieve with the help of the body of influence. So in short, this is the BOI. Okay, so we need to create the body of influence. So here my idea is that I am going to create the two body of influences. One will be like a refined, more refined mesh. So one will be like around this wind turbine blade, and one will be like the outside the whole domain. Okay, so we are going to create two body of influences. So it means that we have to create the two more sketches and two more bodies here. Okay. So one body, and I can show you the sketches like the way I modeled this earlier. So one is like this one, and second one is a bigger body. Okay. And also we need to have the like body influences around the aerofoils, and where we can have the fine mesh. Okay. So for that, and now to create this body influence around the aerofoil, we need to actually go to sketching mode. Okay. For others also, but this is little bit tricky here. Sketch plane number 4, and we have to put the new sketch. So click on the sketch, sketch line, and make a line. That line will be like, you can actually make the line, or you can actually only put the directly point here. Okay. So let's put the line there. Okay. So a line there. And dimension of this line will be equal to 1250 millimeters. So 1250 millimeters. Yes. Okay, so I'm going to make a circle here, over here. This will actually cover my aerofoil. This will cover my aerofoil. All right. But this thing tells us that actually the domain size which we chosen here is like a very small here. And secondly, this circle should be like aerofoil should be in the middle of this geometry. So right now, this, if I take a calculation here, my aerofoil center is actually 30% of the chord length. So that is equal, 30% would be the, how much? This will be the 0.4 meters, and 30% would be equal to the 0.12. It's at the 0.12. But this should have been at the like a 50% of the 0.4, that is equal to the 0.2. So it means that we should offset our circle by how much distance? We should offset this one by the 0.8 meters. By the 0.8 meters. Correct? So I'm going to make a body. Okay. So from the like this simple body, from this sketch, I'm going to make a surface from edges. So sketch number 5. Sorry. We have put the wrong command here. This should be the surfaces from the sketches. So concept menu and surfaces from sketches. So this is going to be the sketch number 5. Add frozen and click on generate. Okay. And then you have to go to the this menu and click on the body transformation and make the option the translate. So we have to translate this body by a distance of the 0.8 meters. So 0.8 meters means that this will be equal to the, so direction will be like x direction, which is normal to the YZ plane. Okay, and should be the opposite. This should be the opposite, this one. And 0.8 meters means that no. It's not a 0.8, but it's a 0.08. So 80 millimeter should be moved by the 80 millimeter. Okay. Now this looks like a symmetric around the aerofoil. Okay. Now decide about its size. Okay. So I'm going to put the dimension here of the diameter. Okay, I'm going to delete. First thing is that I'm going to delete the line here. That is the this line here. One thing. Second thing is that I'm going to put a dimension for this point, center point, and that is going to be the vertical dimension from the x-axis to this point here. So 1250 is okay. Okay, you can click on generate. Okay. Also we need to put the dimension for this geometry here. So the dimension here would be our diameter. So it's a 754. Let's make it maybe 700. And click on generate. But still, you can see this is like it's not coming inside the this boundary. So let's see what I did earlier. Looks like a bigger distance here, and the distance from the circle to the aerofoil leading is small here also. So let's make it maybe like a 600. And click on generate. Okay, let's make it 500. Okay, this seems okay. This seems okay. Maybe you can make it 550. Okay, this seems okay. And now if you go to sketch number 2, which is sketch number 3, sorry. Sketch number 3. So let's make it 1800. And this one as a 3200. And click on generate. Okay, let's hide the sketch number 5. And also hide the plane. So this is what we have the region that this will use for refining a mesh around the aerofoil. Okay, around the aerofoil. So we need to make the two more copies. So I will use the create option and the pattern, and it's going to be circular pattern. And the geometry is this one. And axis would be the a Z axis, which is normal to the XY plane. Okay, we need the two more copies, but two more aerofoils, and click on generate. That's all. Okay, so now I'm going to make another domain that will be body of influence that will be, okay, let me put the names here. So this is the rename body of influence for the aerofoil 1. Okay. Copy, and this is going to be for aerofoil number 2. And this is aerofoil number 3. Okay, once again, save the project file. Okay, now we are going to make the two more body of influences, BOIs, there will be one will be like a very small body around this wind turbine domain, and the other body will be like a bigger body. This will be like will take care of the lot of chunk of the wake region. So I'm going to again put one more sketch here. Okay, sketching, and I'm going to make one line like here. Okay, the point is that this line should be symmetric around the x-axis. Okay, so I will go to constraints and I will use a symmetry constraint, and I want to now make the like around x-axis, but not the any line or surface, only these 2 points. This line will become symmetric of around the axis here. Okay, put the dimensions here for this line. So let's make it like 3,200 and click on generate. Okay, make it like 3,400 or 3,500. Okay, generate. Okay, now I'm going to again draw one more line, and that line will be like in this way. Second line will be like this. Okay, so I'm going to define my dimensions, and this time this will be the angle. So angle here is going to be like this. Right click and choose alternate angle so that we can define the angle over here. So let's make the angle is equal to let's say the 12 degrees. Okay, and move dimensions towards our geometry here. Okay, so now I'm going to actually make the symmetry again between this line and this line. So I'm going to make the constraints, and again the symmetry constraint around the x-axis of this line and this line. So they will have the now same angle. Okay. I will drop a line from from this location, from this point maybe to the bottom line here, and I will use a modify menu, and I'm going to trim my geometry. Okay. So actually we have done this thing, and also I'm going to put the one more dimension. This dimension will be the my dimension of this line from the y-axis. So let's make this one as the 3,900. Okay. Okay, so the angle is 12 degrees, and this dimension is the 3,900. This dimension is the 3,500. And this line will be defined by these two dimensions, angle and the length here, and also this length. Okay, so this is the one sketch. I'm going to create another sketch that is will be the next body of influence. And here I'm going to do the same thing again. So again, the line. Okay. Again, I will put the constraint that is a symmetry constraint. So along the x-axis and these 2 points. Okay, show constraint. You can see that whether we have that constraint or not. So no, right now it's still not. So again, try the symmetry constraint. So x-axis and the upper point and the bottom point. We are not able to select okay, now it's done. So we have the symmetry axis, symmetry curve, symmetry axis, and symmetry curve. Okay. Okay, now put the another line here like this. Okay, I'm going to put dimensions here, and the dimensions for this line. So let's make it like 7,800 or 7,500 or maybe less. Okay, that's okay. I'm going to put the angle here again. So angle here would be some angle. So let's put the angle is equal to 10 degrees. Okay. So 10 degrees and I'm going to draw up a line here, vertical line here, like this. And modify menu, and I'm going to trim the extra parts from here. Okay. So in the dimensions, I'm going to put the dimension of this line from the y-axis and also this line from the y-axis. Okay. So, okay, let's put this line to be equal to the 2,900. Or maybe the 3,000. Or maybe 3,200. Okay. And this line, let's put the dimension is equal to the 12,000 or maybe the 13,000. Okay. So that's okay. We can go back to the modeling tab and we can create the surfaces from sketches. So you can choose the two surfaces, two sketches at the same time and make it add frozen and click on generate. So it actually created two different bodies, not a single body, but two different bodies. So here you can put the name as the BOI1, the body of influence 1. And second one is going to be the body of influence number 2. So BOI number 2. So you can save the file. Okay, now you can actually hide the plane. You can also hide the line direction. You can also hide the vertices. And you can right click here. You can hide the sketches as well. So now you can see that we have the one domain, three domains are there. And also we have the three body of influences for aerofoils. And we have two body of influences for our volume region. Okay. Where we have the wake region and the water shedding will also happen on this region. So now this region can be you can now, depending on the solution, you can extend up to outlet. Sometimes people do that thing. For example, sometimes what they do is that they extend up to the all way around the outside your domain, and that's not a problem. This will only refine the mesh where this domain is. Okay. Outside domain, we don't have anything, so it will not define the mesh outside. It will only define the maximum mesh inside domain. So what the people can do here is that they can extend by the outside. So let's make it maybe the 25,000 and click on generate. Or okay, looks like a body is not symmetric. Okay. So let's make this boundaries, this one as a symmetric. So constraints, and I'm going to put a symmetry here, this, and this. Okay. Okay, now this is okay. And here what I'm going to do is that I'm going to actually put the value here, not 25,000, but let's make it 27,000. So it can go outside our main domain. And click on generate. And you can also change the angle maybe to the 7 degrees. And click on generate. So this is also done. Like if people also do that thing that the mesh should be refined in the whole wake region inside the domain. This is also possible. But let's make it like a smaller. It will otherwise this will take a lot of space, and it will refine the mesh, and this will be actually will take more time to run the case with the more mesh cells. Okay. So that's why I'll make it limited to the only up to the maybe 15,000. That's okay. Or maybe 13,000. Okay. So again, save the file. Okay, save the file. So we have all the domain, all the information with us. Okay, all the boundary conditions are there. Now it's time to actually make the mesh for this wind turbine domains. Okay. So now you should be very much careful actually. When we select everything, it requires some time and calculations. So we should be very patient, and we should be having the like information about the what should be the mesh there and why it should be there. So based on that information, we will like apply some sizes, see the mesh. If the mesh is okay, then we go ahead and we go for the second step, third, fourth, fifth. If mesh is not okay, then we can change the parameter and we can actually remesh and check the again the mesh quality and the meshing, overall meshing on the different portion of the our domain. Okay. So it's time to actually take it to the meshing software. Okay, so double click on the mesh. Okay, any comments on your side? What did you see here? What you learned here? It's a complicated or what do you think? It's a complicated, easy, difficult? Uh, definitely, because it's the first time for you. But if you take just concentrate on the procedure, okay, and why we are doing that thing. Yes, obviously. Okay, one more thing is that I think that this is also symmetric or not. So just make sure that we have the symmetry condition also applied on these two lines. Okay, so I will go to constraints, symmetry between these two lines. Already we have the symmetry. Okay. And you can also change the color by the name selection like this. Okay. So now we are opening that thing in the meshing software and just make sure one thing in the geometry. If you go to the properties, 1 minute. Okay, thickness is a 0. Okay. So just make sure the thickness is 0 because the 2D case, the thickness should be equal to 0 meters. Okay. So now we are ready for our meshing practice here. First thing is that I'm not going to work first with the body influences. My first goal is to actually put the proper meshing on the different edges and different faces. Okay, especially on the aerofoil. So first I will suppress them and then I will be working with them one by one. Okay, one by one. First I will go with the body influence for the aerofoil 1. Same setting I will to make it for 2 and 3. Then I will also be making setting for body influence 1 and 2. Okay, so first we start with our basic mesh. So I would recommend one thing that you can also actually hide this or just suppress this domain as well. Okay, so suppress the body. So just concentrate on the meshing in this region. Okay, in this region, right? So just give me 1 minute. Okay, so we are still working on our meshing part. Okay, so first we are concentrating on our middle domain, which is the most important domain actually. So first thing I will start with our aerofoil. Okay, so aerofoil should have the 3 edges here. So I'm going to put the sizing here. So a sizing should be done on the aerofoil surface. So first I will concentrate on my leading edges, all three leading edges in a single go. Okay, so these 3 edges. Uh, 1 minute. I think we should first make the mesh for this geometry. Okay, or maybe we can consider on the aerofoil on leading edge. Okay, let's start with the leading edges. Then we will go for these internal edges. Okay, so box selection. So I will select them with a box, and I can select them all in a single go in this way. So I will putting the number of divisions here, and I'm going to put the number of divisions equal to maybe 15. This is going to be the very uniform mesh. 15 cells are here. Okay, now click on the generate. Simple. See, are we able to resolve the mesh on the boundary on the leading edge or not? So now it's okay. Okay, now put the mesh size on these aerofoil surfaces. Okay, top and bottom. So again sizing, and this time I'm going to choose them by clicking from the right to left. So from right to left, what happens is that we don't need to select the like a full geometry. So just selecting the like some touching the box will actually select our geometry. Okay, like this way. So just the box should be touching that particular geometry and it will be selected. But if you go from left to right, then you have to like put all the geometry inside the box. So here I'm going to put the number of cells equal to the like maybe starting, it can be like you can start with the 60 cells here. Okay, and click on generate. So 60 or maybe 80 or maybe 100. Okay, we should also be putting the meshing method here. That meshing method, we can work with this type of the hexa meshing. This is the pave hexa. Or we can also go with the tetra meshing. It's your choice. So let's make the method as a tetra meshing. Okay. So make the selection as a single select. And I will be using the triangles and click on generate. Like this. Okay. Then I'm going to put the inflation. So before I put the sizes on these edges, I'm going to put the inflation on my aerofoils. Okay. So boss select them. Okay. First, sorry. First is that we have to select the body where I want to apply the inflation. And then I have to select the boundary, those boundaries. Okay. So that name selection should be there enough. So name selection would be our wind turbine. Okay. The wind turbine means all blades, all 3 blades. So it select all the boundaries which are inside this single boundary condition. Okay. So the number of layers we have right now, they are 2. So just make them like a 20. Okay. Make them 20 and click on generate. At least 20 cells should be there for the resolution of the boundary layer, like these type of the cases. Okay, this seems okay. We need to define the at least 2 or 3 cells on the trailing edge. Okay, so that's why I'm going to put the sizing here again, and I'm going to put the number of cells equal to the 3. So it's a box selection. So 3 leading, sorry, trailing edges. So apply. Okay, if we cannot select them, then you can actually select them with a single click. Okay, so select this boundary. Okay, sorry. Age criteria was not set. That's what the problem. Okay. So now you can again try with that box selection. Okay, the age, the selection criteria was face, not the age. So we can select them like in this way. Okay, so I can put the number of deviants equal to the 3 here. And click on generate. Okay, tolerance value problem is there. So it should be like rule of thumb is that the tolerance, the deficient tolerance should be 1/10 of the minimum size. So let's make it very small value. So in the sizing, let's make it like some small value. Let's make it 10 power minus 5. So 401 and click on the generate again. Okay, so now just check the mesh we have here. Okay, this actually looks good very. So that's a good thing. Okay, I think we should increase number of layers to the 30. Okay, and click on generate. Problem is that we are not able to actually expand our inflation layer. So let's make it, okay, use the transition ratio as 0.4. Okay, so I want to actually have the boundary thickness should be like up to here. It should be like up to here. Okay. It's still the same problem. Okay, so make the growth rate is equal to 1.25 and click on generate. Okay, let's make it like 0.6 here. Okay, now this seems okay. Okay, this seems okay now. Okay, so I'm happy with this inflation layer settings. Okay, now the next thing is that we have to actually put the defined mesh on this surface. So I don't know what size right now we have. I can get the idea from here. So I can actually take the one triangle. Its length is like right now it's a 0.05. Okay. So let's choose the size of the our face size here to the 0.05. Okay. So sizing, face sizing, and make the size is equal to 0.05. Okay, click on generate. Okay, this seems okay. So 0.05. Okay, let's enable the our inner domain. So unsuppress. Okay, so choose this one and make the sizing here. Okay, so same size here as well, 0.05, and click on generate. Okay, it is showing us the different meshing. It is also okay, but you want to keep the same one, then you have to use the meshing method. It should be the triangular mesh. Okay, so it should be triangular elements, and click on generate. Just give me please 1 minute. Okay, so we have the now very nice mesh actually. So here we have to now refine the mesh around the aerofoil itself. Okay. So I'm going to put the size of the aerofoil. Right now it's a 0.05. So size around aerofoil I'm going to put is going to be like half of this value actually, at least, which is the 0.025. Okay. So now I will enable these three body of influences. So unfreeze them, unsuppress them. So I'm going to put the body size. These are the body sizing. Even they are 2D cases, but these are bodies. So we have to put the body size, okay, not surface size. These are the bodies. Bodies will always go inside the body, okay. Doesn't mean that the body can be the line body also. It can be surface body. It can be volume body, okay. So it's a separate geometry which is now defined in like here, like geometry, and here they are different bodies, okay. So we have to put the body sizing. So click on sizing, and geometry on which we are going to apply the sizing is over here. And what we are going to do is that we have to put the body of influence. And how many bodies are there? Three bodies. This, this. Okay. Let's use the box selection. Okay. Let's use the box selection. So we will go in this way. 1, 2, and 3. Okay. And the size, what I'm saying, the size I'm going to put is actually is going to be the half the size, at least the size we are putting on this whole surface, which is the like a 0.05. The face sizing was 0.05, right? Half value would be the 0.025. Okay, click on generate. Okay, this looks fine. Let's go with the somehow even smaller size. So let's make it 0.015. Okay, it should not be very fine actually. Too fine is not required actually. So I'm trying to be okay. This seems okay. This seems okay actually. Because the mesh size here is the same size of the elements which we are actually having the aerofoil. So, and it should not also make any issues with the transition from the these map elements or the rectangle elements, elements towards the triangle. Triangle should not be very small. So let's make it maybe the best size would be the maybe the 0.018. Okay, and click on generate. Okay, this seems okay now. From my point of view, this is okay. Okay, any questions? I think this is the I would say we have heat transfer case is remaining for the ANSYS meshing, and also in the fluent meshing some things are there. I will cover that in the end of this course. But right now you can see this is like a very much the new things. This is like I think this is like some perfection of the meshing. If you learn this thing, then you should be able to make the meshing for the any case actually, right? Any questions? Any questions? Okay. So now what we have to do is that actually we are going to freeze the mesh here. So now I'm going to open the outer domain, which is here. Okay, so unfreeze, unsuppress. Okay, and here what I'm going to do is that I'm going to freeze the mesh here. So mesh should not be disturbed here actually. And this is my the run domain. Also, I'm going to actually freeze the mesh here as well. Okay, I'm going to freeze the mesh right now here. And definitely, I will freeze the mesh after actually applying the my first body of influence here. Okay. So here, what size I'm going to put is like the size we have the on the this faces is equal to 0.05. So size in the body of influence I'm going to put is maybe like a 0.1. and then here maybe it's the 0.3. Okay. So let's see what we have here. Okay. So again, I'm going to put the body sizing. So body sizing, and I'm going to put the sizing on all the geometries, like my inner domain, my middle domain, my outer domain. This body influence actually is covering all three domains. Okay. So that's why I'm going to choose all of them like with the box selection. First, I can do with the box selection. These all domains. Okay, so I have to unfreeze the mesh here. Okay, so unfreeze the mesh. Okay, and these three body influence are not required, so you can hide them. Okay, so now go for the body sizing and select them with the box selection like this. Okay, so then you can change your box selection to the single selection mode. Again, click on this geometry, and this time click on the control key, press control key, and then select our outer domain. So actually we selected three bodies here. The body influence will be only one, this one. Okay, this will be refining mesh in the all three domains. Okay. So this is going to be the body of influence. Which body is there? This body is here actually. This one. So click on apply, and size we are going to put is a 0.1. Okay, double the size which we have here. So you can click on generate. Let's make it not 0.08, but not 0.1. Let's make it 0.08. Okay, and click on generate. Okay, this is making again the chord element. So we have to make the method for this domain and make it like a triangles. Okay, and click on generate. Okay, this looks very fine mesh actually. So let's make it like 0.1 as we did, as I said earlier, to make it 0.1. Okay, and outside I'm going to make it 0.3 or maybe 0.4. Okay, second body of influence, that is going to be the here. So geometry will be only this domain. And here we have to actually freeze the mesh here. So freeze mesh here and freeze mesh here as well, because they will not be affected by this body of influence. So freeze the mesh. And then you have to select the body sizing here, and change the body sizing type to the body of influence. And this is going to be this body. So use the second plane and make the sizing as a 0.3. Okay, and click on generate. Okay, this seems like a very coarse cell. So let's make it like 0.2 and click on generate. The mesh on the part is frozen. Okay, what message we are getting? The mesh on the part is frozen. Please unfreeze the mesh, and then name selection generation should be allowed. Okay, so now I think that every setting is all right. So I can now actually unfreeze the mesh here, and then I can actually create the mesh once for all the parts in a single go. Okay, so click on the generate. You can actually clear the mesh from all the domains. Okay, and once again you can click on the generate mesh. Okay, so you can actually update your mesh, and if we don't have any problems, it should actually translate the mesh for the Fluent. is any problem with the meshing? Okay, we have the connection problem, so we can delete them actually. I will make the interfaces myself, so I don't need the connect regions inside the ANSYS meshing. So just delete them. Okay. Okay. Once again, go for the update. Okay, so you can see mesh transition to Fluent was successful. Okay. This was like a making problem, so now it's okay. You can save your project file. Okay. And then we can go for the yes, very much. No problem. So tomorrow we will be we'll be working with our Fluent simulation. Okay. So today we finished the meshing part, and we finished some part of geometry and also the meshing part. And the mesh right now looks like a mesh I have created earlier in these slides. You can see them. So what do you say? That's okay. So here, same thing like we have here. Same thing, but here the body inference domain is actually large here. So you can actually change the length of the, because we already put the dimensions here. You can extend up to the like almost like outlet. Okay. So now we should end here. Any questions you can put on the chat box or maybe in the WhatsApp group. Okay. So see you tomorrow again. Thank you. Bye bye.